Well, we've made it to the last lesson that we will cover in Chapter 5, 12.5, or sorry, in Chapter 12, Section 12.5. We do take a couple days going over this as far as videos, however, we'll get all the videos done in one night and take 2 days working on it in class. So we are going to learn how to add and subtract rational expressions. So in order for us to add and subtract our rational expressions, we need to remember how do we add and subtract just regular fractions. So the main thing to remember when you add or subtract is that you need a common denominator. So some fractions will have a common denominator, some fractions will not have them. What this book does is it calls them like fractions and unlike fractions. So if you notice this first example, 5/3 plus 7/3, the denominator is the same. There's already a common denominator, so the book calls these like fractions. So when you have like fractions or a common denominator already, we get pretty excited. That means there's less work to do. That denominator stays the same, and then all you do is you add the numerators. And then once you get your final answer, you do want to see how you can reduce that. So that would just equal a 4. Now, what if you have unlike fractions, which means that your denominators are not the same? So we can use multiplication to get a common denominator. Between 8 and 3, the lowest number they fit into is 24. So we're going to take this one on the left, multiply it by a 3, and whatever you do to the bottom, you also have to do to the top. So that gives us 15 over 24 minus, and then on the right, let's go ahead and take that 3 and multiply it by an 8, top and bottom. So we get 16 over 24. Now that we have created like fractions and we have a common denominator, we can go ahead and do the math. Again, your denominator stays the same, and then all you have to do is the math with the numerators. 15 minus 16 is a negative 1. Reduce if you can. This one, however, does not, so we have negative 1 over 24. Alright, so we just had our refresher on how to add or subtract fractions. So now let's take a look at how this works if we are adding and subtracting rational functions. So I'm going to take a look at this one on the right first. I'll go ahead and move it over here. So here's an addition problem. First thing we want to look at is the denominator. Is the denominator the same? If it is, again, we like that it is, it's less work, but we just want to make sure we keep the denominator the same. So that's going to stay in x minus 4. And then what we're going to do is we're going to take the numerator and we're going to do this addition. So you have x squared minus 8x plus a 2x plus an 8. So basically all that we're able to do is combine like terms. You have an x squared. Are we adding any more x squareds? We're not, so that x squared stays. And then you have a negative 8x plus a 2x. We can go ahead and put those together. That's going to give us negative 6x. And then plus that 8 does not have a like term, so plus 8. Alright, so this is our answer unless we can simplify it. So this takes us back to probably 12.3 where we were simplifying rational expressions that look like this. Anytime you're simplifying, remember it's all about factoring everything and then seeing what can cancel. So this trinomial x squared minus 6x plus 8, do we have factors of negative 8 that will add up to a negative, factors of positive 8 that will add up to a negative 6? And in this case, we do x minus 4 and x minus 2. And then the denominator x minus 4 cannot be factored. So now we have everything factored. What do we see on the top that can cancel with the bottom? Well, the x minus 4's cancel away, and it leaves us with just an x minus 2 for our final answer. Alright, well let's try another one of those. So I've got one, here it is. So an subtraction problem this time. First look at your denominators. Are they the same? They are the same, so we can go ahead and keep that the same. That's going to stay in x squared minus 4. And then we'll go ahead and do the subtraction with the numerator. So work on subtracting your like terms. You have a 5x minus a 2x. Well, 5x minus 2x is 3x. And then you have a 2 minus a negative 4. So 2 minus a negative 4 actually becomes 2 plus 4, and 2 plus 4 is a positive 6. So be careful with that subtraction. You might be subtracting some negative values, which will change its sign. Alright, so here's our answer unless we can simplify it. And again, when we simplify it, we're factoring everything and seeing if we can cancel anything out. In the numerator, we've just got a GCF you can take out, and it leaves you with 3 times x plus 2. In the denominator, can we factor x squared minus 4? And we can. X squared minus 4 factors into an x plus 2 and an x minus 2. That's our difference of squares pattern. So now we look for anything numerator versus denominator that can cancel. Your x plus 2's can cancel, and it leaves you with a 3 on the top and an x minus 2 on the bottom. And there's our simplified answer. Alright, so now we're going to get to the ones that are a little bit trickier, our unlike fractions, which means that your denominator is not the same. So basically the approach that we take on these is working on building up our denominators to make them the same so that we have a common denominator. For an example like this, if you notice there's no addition or subtraction, so we can't do any factoring to help us out, you want to just look at it piece by piece. First, we have a 6 and we have a 4. So what's a common denominator between 6 and 4? Or what's the smallest number they both fit into? And that would be a 12. So on the left, we can go ahead and take the 6, let's multiply it by 2 to get it up to 12, and let's multiply the top one by 2. Now on the right, how do we get a 4 up to 12? Well, we multiply it by 3. Alright, so that's going to give us, and maybe I'll write it down. We have 6x over 12x squared plus 6x again over 12x. Okay, so this middle step I'm writing out, I'm just kind of writing it out so we can talk about it and see what we have. So now the 12 is the same, so that part of our denominator is common. What we need to do next is figure out how to get the same number of x's. You have an x squared on the left, and on the right you have an x. We can use multiplication to make these the same. So on the right, if I multiply this side by an x, so basically it's like I'm putting an x over here on the right, on the top and bottom, that's going to give me the x squared to match this over here. So I'm going to rewrite this. We have 6x over 12x squared plus 6x squared, multiply the top, over 12x squared. So you have to do that first step of getting your denominators the same. So now that we have a common denominator, you can see we have 12x squareds, we can go ahead and do this addition. So remember the denominator stays the same, that's going to be a 12x squared, and then we're going to go ahead and add the numerators. They are not like terms, so let's go ahead and do the highest exponent first. 6x squared plus 6x. Alright, here's our answer unless we can simplify it. So for our simplifying, we'll try to do some factoring. On the top we can take out a GCF of 6x, and it leaves us with x plus 1. In the denominator we have a 12x squared. So we can go ahead and reduce the 6 over 12. That reduces to 1/2. That becomes a 1 over 2. Maybe I'll just cross those off. And then if you have an x over x squared, you can reduce those. The x on the top actually will cancel out one of the x's on the bottom. And in the end, you're going to have the x plus 1 on top, and on the bottom you're going to have your 2, and then just an x to the first power. And that's our final answer on that one. Alright, so last one of our unlike fractions in our intro video, and I know these are kind of long, but again it is the last night of videos for the chapter, and then we have a lot of review days coming up. So we have to subtract these fractions. We can see the denominators are not the same. And do you see how this one has some addition and subtraction? What you want to know is maybe they already have something that is common in the denominator. So we want to see the denominators in factored form. So we're going to go ahead and factor our denominators first just to see what the problems actually look like. So factors of positive 3 that add up to negative 4, that's going to give us x minus 3 times x minus 1, minus, then the 2x minus 2 will stay on top, over, can we factor a 3x minus 9? Let's take a 3 out, and it leaves us with x minus 3. Alright, so here's why that was really helpful to do. Do you see how they both already have an x minus 3 in the denominator? So that's common. We don't have to worry about putting in more x minus 3's. What I do notice is there's an x minus 1 in the left fraction, so we're going to go ahead and put an x minus 1 on the right, but if it's on the bottom, we have to put it on the top, x minus 1. I'm going to go ahead and throw that 2x minus 2 in parentheses. Alright, so now they both have an x minus 3 and x minus 3. They both have an x minus 1. What's missing? Are they the same yet? Well, this one on the right has the 3. So we're going to go ahead and put the 3 on the left, bottom and top. We'll go ahead and put that in parentheses. Whew, alright, so now we have common denominators, but we need to clean this up a little bit. In the numerator, because all of this is going to end up getting combined, we do want to go ahead and multiply this out. So we can distribute the top. We have 3x squared minus 3x. The denominator, though, we will leave exactly the same. We're not going to touch that. It's less work, so we're kind of excited about that. Minus, now how do we multiply this? We actually are going to FOIL that. So maybe over here on the side, we can go ahead and do that foiling. First, 2x times x is 2x squared. 2x times negative 1 is minus 2x. Negative 2 times x is minus 2x. Negative 2 times negative 1 is plus 2. It leaves us with 2x squared minus 4x plus 2. So when I come over here to our fraction, in the numerator, I'm going to have 2x squared minus 4x plus 2 over, and then the denominator stays the same. This feels like the never-ending problem. Whew, okay, so here's what we're looking at. Let's just get all the rest of that out of the way. Do you see how our denominators match? So we're good there. So our answer is going to have that denominator, the 3 and the x minus 3 and the x minus 1. All we have to do now is subtract our like terms up here. First we have 3x squared minus a 2x squared. Well, that leaves us with just 1x squared. Then we have a negative 3x minus a negative 4x. Negative 3 minus a negative 4 does become plus 4, which is a positive x. And then we just have this minus a 2. If you can hear my dog, she's whining at me right now. So I'm ignoring her for a second. Alright, minus 2. Now, here's our answer, unless we can simplify it. Can we factor the numerator to see if anything will cancel with the denominator? That's why it's nice to leave your denominator in this factored form like this to see if anything will cancel out. So, factors of negative 2 that add up to positive 1, we can do x plus 2 and x minus 1 over 3 x minus 3, x minus 1. Alright, now that we see everything factored, you can see your x minus 1's cancel, leaving us with x plus 2 on the top, and a 3, x minus 3 on the bottom, and we are done. And I'm sure this turned into a really long intro video, so sorry about that, but last videos of the chapter, so there's the bright side.